So this and the next two questions, it looked like all of them involved the spring force. So I thought I would do them as a group. Let me now read the question carefully. This is, by the way, question 60 something, problem 65. It's kind of long looking question because of this image here. Consider the baby being weighed in the following figure. What is the mass of the infant and basket if a scale reading of 54 Newton is observed? Okay, so if that's the scale reading, I mean, I can draw a free body diagram of the baby. I mean, it's kind of drawn here, but I like to draw free body diagrams in a way it looks a lot simpler. Like baby's a dot, and the baby has a weight that's going to be mg according to the formula, and then upward force of the, it says tension force, let me use the symbol ft, and the spring scale is basically reading this force here through this portion here. So we can say the question gave us this force is 54 newtons. And I think most people have good enough intuition here. Looking at this picture, you kind of know the baby probably isn't accelerating. So you can say net force is equal to 0, which must mean the weight is equal to Ft. So that Ft is equal to mg. Question is asking for m. So you solve that for m is equal to Ft divided by g. Now, is this the kind of calculation I can do in my head? 54 divided by 9.8. I might be able to. So, if I use g approximately equal to 10, then it should be 5.4. Now, I have a feeling that's going to be graded as incorrect because it's off by like 2%. And it's 2% too small. So I can make it back 2% bigger. So it'll be 5 point something like 508 maybe. Let's give that a try. Now it might be within the precision. Yeah. But yeah, you get it by the tension force divided by g. What is the tension in the cord attaching the baby to the scale? Oh, I kind of said that it's already that, so that should be 54 newtons attaching the baby to the scale. Yeah, yeah, that's I think most people can answer this intuitively, and I don't want to overcomplicate it. Now the next part is potentially complicated because it's asking what is the tension in the cord attaching the scale to the ceiling if the scale has some mass. If you're thinking, oh, shouldn't it be the same? No, this is where you probably should draw a free body diagram to kind of correctly analyze the picture here. So let me draw a free body diagram of the scale. So the free body diagram of scale is, yeah, and this the diagram that's drawn here, it's not a free body diagram because it's missing some forces. So let me represent the scale with a dot, and I'll draw some of the forces that I know has to be there. There has to be this T1 pulling it down, and the T1 we know, it's the 54 Newton that we had from earlier. T2 is pulling it upward, and this is what we are trying to find. We don't know. And you might be thinking, oh, I'm done. That's all the forces. And if it were, T2 would have been 54, and that would have been correct answer. So the force that you have to remember, especially since they tell you the mass of the scale for some reason, is there's gravitational force on the scale. So there has to be the weight of the scale, which is going to be equal to mg. And from Newton's second law, the net force is going to be T2 upward force minus the sum of the downward forces. So T2 minus mg plus T1. And hopefully you have enough intuition to say that this is not accelerating. Acceleration is 0. So the net force from Newton's second law, mass times acceleration, should also be 0. So T2 should be mg plus T1. So in addition to T1, you have to add this mass of the scale times g, 9.8. So let me see if I can do this in my head. So if G is 10, then it should be really 54 plus 3.5, so 57.5. It might grade that as correct. That might be within 1%. Let's give it a try. Yep, it's within 1%. Now, so I think the answer is probably a little bit off, but I don't want it to do it in my head, so that's why I am. So that's why this is slightly off compared to this, but most of the questions will use 1% relative tolerance. So as long as you are within 1%, even if it's a little bit off, it'll be graded as correct. So, yeah. So let me get to the other two questions. All right, so this is the next question. When I was reading quickly through, I just saw the word spring, so I thought they were related, and they probably are. So a mass is suspended from a spring hanging vertically. Okay, let me start by just in lieu of my usual doodle, just drawing free body diagram. So let me leave that dot there. It's not gonna be a scale anymore, it'll be a mass. So mass is suspended from a spring hanging vertically. So I guess there must be an upward spring force, and then there's always gravity, so there's probably downward force mg, and we are given the amount of mass, and this time the question is telling us how much the spring stretches. And once you get this far, then I hope you remember what we call Hooke's law. This relates the magnitude of the spring force, or actually the spring force as a vector. It relates the spring force to displacement. It's minus k times delta x as a vector. So it asks how much will the spring stretch if the suspended mass is this. Now there are more elegant ways to do it, kind of do all the algebra so that you have to plug in all the numbers all at once, get delta x that way. But let me just go a little bit slower and kind of figure out intermediate quantities. So from the information that's been given so far with how much it stretches, I think I have enough information to actually figure out the spring constant. So I can say my spring force here is k times, let me call this x1, that's been given 6 centimeters, and I'll just figure out k, and then once I know k, then I can recalculate the distance of how much it stretches, delta x, with a new mass, 460 grams. So I have enough intuition that acceleration here is 0, and I've done this question enough to know with the 0 acceleration, this upward force should equal this downward force. So I'll say the spring force is equal to, in magnitude, equal to mg, which means mg is equal to spring constant times x1. Solve this for spring constant. Mg divided by x1, and I'll work it out here, and I'll just put in all the units and have O from alpha to the final conversion. 250 grams times 9.8. Oh, I can just say gravitational acceleration, and it'll know what it means. Divide by the amount it stretches, 6 centimeters. So that'll give me spring constant in like a Newton per meter, 40.86 Newton per meter. So I'm gonna from here on treat spring constant as a known quantity. I have a number that I can plug in from my calculator anytime I want. Now, knowing the spring constant, now what changes is we have a new amount of mass. Let me call this M2. This is now going to be M2, which will result in a different amount of stretching. Let me call this X2. So this will be X2. Other than the change, everything actually remains the same. We are still looking at when the acceleration is 0, when it's come to rest and not moving. So my equation that I set up is still kind of the same, just with the different symbols. M2 and X2. And I'm solving for X2 rather than K. So let me do that. So solving for X2, it's going to be M2G divided by k. And I think I can do this calculation within Wolfram alpha. I know this particular combination of quantities is my k, so I'm gonna end up dividing by that in the end. And I have m2, 460 grams, times, again, gravitational constant, acceleration, which I think will cancel out. All of that divided by that. So that should give me something in the unit of length, meters or centimeters. Let's look here. Yeah, centimeters, 11.04 centimeter. So that should be correct. Yep. Pretty simple. Involves spring. Let's look at the next question. 86. I'll do previous maybe. So let's look at the next question. I think that's the previous question here. Let's look, 89. Yeah, I think that's the one. Let me just erase this part of the screen. In building a house, carpenters use nails from a large box. The box is suspended from a spring twice during the day to measure the usage of nails. The beginning of the day, spring stretches that amount. At the end of the day, spring stretches that amount. What percentage of the nails have been used? Interesting. Let me first kind of sketch out, maybe draw two free body diagrams. And I guess here I can try using slightly different approach. So in the previous one, I basically worked out intermediate number. But you know, you don't have to do that. You can actually do the whole thing just purely algebraically. So let me just kind of lay out the path that I'll follow. So free body diagrams. So here's the morning measurement, and here's the afternoon measurement. So there's gonna be the spring force that's in the morning. So let me call this actually FA. That's going to be related to the spring constant, which will be constant, times, and the question gives us the different amount of stretches in the morning and afternoon. So I'll call this XA. And in the afternoon, there's still upward spring force when you are weighing it. That'll be FP for PM. That's equal to same spring constant times XP. Now, these are not the only forces at each instances. There should be gravity, so downward. So the amount of mass, so that'll be, let me call the, what percentage of nails have been used. So, there's some ambiguity in the question here. If I'm just reading what percentage of the nails have been used, I'll be looking for delta M divided by like mass of the thing in the morning. But that's not what this is saying. Let me calculate it this way and see if it'll be graded as correct. If not, I'll just try to figure it out. So let me use these symbols here. The mass of the thing in the morning times G, and the mass of the thing in the afternoon times G. And really what I'm looking for right now, assuming I'm reading the question correctly, is I'm looking for delta M over its original mass in the morning, or the MP minus MA divided by MA. That's what I'm looking for. Let's see if the number I will calculate will be graded as correct. So it would be nice to have some expression for the masses of the things. And in thinking about that, I have enough intuition that all these are happening at zero acceleration. So I can write down this equation that compares these two forces. So I have the spring force, KXA is equal to MAG. And from the second equation, I also have KXP is equal to MPG. Can solve each of these for the mass that I'm eventually going to use. Both of them will have some additional unknowns, like I don't know the spring constant, but looking at this expression, I have some sense that it'll cancel out. So even though I have, it might look like I have too many unknowns, I'm just kind of hoping, trusting and hoping that algebra will work out and just working through. So mass in the afternoon is kxp divided by g. So let me just plug in these two expressions into here, and let's see what cancels out. Writing it all out. This is equal to, let me write down mp, kxp over g minus ma, kxa over g divided by ma, kxa over g, and I see common constants that I can just cancel out now. K is common in every single term, so basically I imagine on the numerator factoring out k and then cancel that with the k in the denominator, and same thing with the division by g, so that should cancel out. So I get as a kind of final expression that I think ought to be graded as correct as the displacement in the afternoon minus displacement in the morning divided by the displacement in the morning. Let's see if that'll be graded as correct. So I think I can just plug it in all as just the numbers without units. xp is 30 centimeters, and yeah, I guess it'll be a negative number because the mass is lighter in the afternoon. So 30 minus 35 divided by 35. Now it probably isn't looking for a negative answer, so so that times 100 for percentage figure. So I think it should grade 14.29 as correct. Let's see if it does. 14.29. Yeah, it doesn't grade it as correct. Now if I'm reading, okay, let's try to judge the question writer's intent. You know, M2 over M1. Okay, I think by M2 they meant mass of the thing in the afternoon maybe, and by M1 they meant mass of the thing in the morning. Then okay, I'm thinking through, so imagining doing something similar, you know, so I'm just trying to figure out, again disagreeing with how it's been done, but just to I'm just trying to get at the answer that system will grade as correct. So if I'm trying to figure out, okay, what is mp over ma instead of the expression I had, then I think I can imagine going through all the algebra, and I think I'm just gonna end up with xp divided by xa. Let me try that. So that'll be the 30 divided by 35 times 100. So, you know, 85.71. And that's graded as correct. So I'll write something to the question author. I think for someone who's reading this portion, people can figure it out. What probably should be done is we write this to say what's the ratio of the mass of the nails at the end of the day to the mass of the nails at the beginning of the day. And you know, if you want this, then you can figure out, okay, then it's 100% minus that, and that's the number that I was plugging in before. So that's the three questions that when I looked at it, looked like it has something to do with the springs.